Power quality itself is luxury in the power world. I know that AI can't replace the job of a power quality engineer. Even if the engineer is going to use AI or use AI tools, read, learn as much as possible. Being open to learning and growing is a big deal. Figure out what other people are doing and see how you can benchmark and improve. We have the huge problem of affordability in the US, which is something that used to be just an African problem. Find people on LinkedIn that are doing this kind of stuff you're interested in and talk to them.
Dynamic Ratings partners with utilities to successfully implement integrated asset monitoring solutions that reduce unexpected outages, improve reliability, extend asset lifespan, and deliver measurable results. My guest today is Urenna Onyewuchi. Welcome. Great to have you here on the Grid Knowledge podcast today. And, we've known each other for probably about a month or two. We've got into a conversation about some of the leadership that you've had with IEEE and some of the things you're doing in the industry. I'm familiar with your background a little bit, that you've had a CEO of a consulting firm. You've had leadership roles not only with IEEE, but with Corning, and now with an electric utility. Tell us a little bit about your background and your current role, so others can get a little more familiar with you.
Sure. So I was born in Texas, but I grew up in Nigeria, West Africa. And
no kidding.
There, power on its own was a luxury. We would get max of 1 hour from the grid a day and would supplement it with diesel generator. So I would be in school throughout the day, and then when my siblings and I would come home, my dad would turn on the diesel generator, and that's what we used to study at night.
Wow.
And it was very frustrating from a noise point of view, from an environmental pollution point of view. I just remember growing up saying I was going to change the face of power in Nigeria.
Well, that is quite a story.
Yes.
You went from only having grid power for an hour a day to getting a Ph.D. EE from Georgia Tech. And then no wonder I can see where the passion's coming from now. Okay. Wow.
Yes,
So
exactly.
tell us more. Then what?
Sure. In graduate school, I specialized in assets management of power systems.
Okay.
And during that research, I became knowledgeable about the work that Osmos does for utilities in the Georgia and East Southern area, basically. And when I started working for Corning, I got into the field of power quality. So it wasn't a part of power that I had studied particularly, but I gained interest in it and became the subject matter expert for power quality at Corning. And I continued to work in that space. I talked about power being luxury in Nigeria. Power quality itself is luxury in the power world, because you talk about power reliability, that's what most people talk about or think about. But power quality is very important, because when it's not there, especially industrial plants suffer. So I continue to work in that power quality space, and right now also dabble into the DER interconnection space. So
very interesting.
Of distributed energy resources to the grid.
Which power quality is a pretty hot topic, right? With
Yes.
With that, for all kinds of reasons. One of the areas that I've been interested in the past is really the switching power supply aspect and how that impacts the reliability and longevity of components. But anyway, that's fascinating. So with Corning, were you trying to make sure that the power was of high quality for your industrial processes? What did that look like?
Yes. So when I was brought in, the executives needed to understand precisely what was going on. So for instance, they would be told that a 2-second event would cause a 4-hour outage or downtime on the process.
Okay.
So they didn't understand why.
And what were they manufacturing?
So Corning has different divisions.
Mhm.
You have the display technologies division. So
Okay.
that's manufacturing glass. So glass that goes
Okay.
on stuff like TVs and
Mhm.
smartphones and laptops and the rest of them. Then you have the environmental solutions division. I'm
Mhm.
not saying the exact names correctly. But
Sure, generally
environmental.
speaking.
So they make ceramic substrates that
Okay.
go in cars to clean out the soot and make sure that what comes out of it is cleaner air.
So in essence, if
and
they were
then-
making this glass and ceramics, if they had a 2-second blip, that would make a huge issue for the process, and you'd have a significant outage. Obviously, would be huge impact from a probably not just reliability, but also financial impact too, right?
Definitely.
Mm.
Definitely.
Well, that's fascinating. And now you're also working as a subject matter expert for an electric utility in power quality. Now, how does that look from the other side now? You used to be from the industrial side. Now you're looking at it from a utility point of view.
Great, great question. It is very different.
Mm.
So when I was doing power quality in the industrial space, I needed to have a good understanding of IEEE 1159 and the different categories of power quality. So voltage SADs, for instance, are the most popular types of power quality events that take place. I think over 70% of power quality events are voltage SADs. And oftentimes the customer will almost always assume that the fault is coming from the utility. But after we investigate, it's typically that it's coming from industry. Now, in the utility space, they care about regulation and policy. So IEEE has a standard called 1547 that provides limits on different concepts. So in terms of harmonics, how much distortion is allowed. And then you have rapid voltage change, and you have different types of power quality events and their limits to it.
Okay.
So that the developers of the different distributed energy resources have to make sure that their system is not going to put, I'll use a layman's term, dirty power into the grid.
Right. Mm-hmm.
And that's very important on the distribution level as well as the transmission level. So at the transmission level, we're dealing with IEEE 2800. And there it specifies, again, other limits that the developers have to make sure that they don't exceed. So at the transmission level, for instance, power quality meters are a necessity. You have to put in meters so that the utility can measure the quality of the power that you're putting into the system.
I'm curious. This is putting my technical hat on. This is my geek hat, and say, do you have a sense, or is there specifications? And if you don't know it off the top of your head, that's fine. But are there specifications for the bandwidth of those power quality meters? Like, for up to what frequency are they measuring, or do they use like so many harmonics of the power frequency to describe that bandwidth? How is that measured?
It specifies up to the 50th harmonic.
50th.
So we're
Okay.
looking at about 3 kilohertz for a 60 hertz system.
Okay. That's
And
fairly high.
So, I mean, I might mention this later, but some meters, power quality meters, can measure up to the 80th harmonic or the 100th harmonic, while some others just stick to what the standards call for now, which is that 50 harmonic, 50th harmonic order. But if you're trying to prepare for the future, it might make sense to do more than the 50th.
Yeah, I certainly think so. What I've seen with solid dielectric, like plastic and rubber materials that are used for insulations, that they can be significantly adversely affected by high frequency, high voltage. And I've seen scenarios where people will say, well, we don't have harmonics, we don't have power quality issues, and yet when we're looking at it with a much wider bandwidth, we're seeing spikes that are in excess of 2, 3, 5 times operating voltage, but the pulse width is so narrow that the lower bandwidth meters, they look like little nubs on the sine wave, as opposed to the spike that they are, and that is creating voltage transients and damage to solid dielectric components. And I know there's some research being done in this area, but anyway, I digress. So it sounds like, I mean, you've got a Ph.D. EE. You're working in the power quality area. You've got a deep background. You said you did some work with Osmos Utility Services and from a research standpoint on aging infrastructure. And you've got this leadership role with IEEE. I want to talk more about that, but tell me a little bit about your current role and how you're using power quality. I mean, you gave me some building blocks there, but did you want to say anything more about what you're working on currently, some of the challenges that you're working on and how you're solving those?
Sure. So a customer might make a complaint, maybe through the customer service office, and say that they are experiencing some issue. So I generated a process map for, when the data comes in, who should it go to? So for instance, should it go first to division engineers who would have be able to go to the database and say, okay, there was a trip and reclose on that same date. So we always ask the customer, what days are you talking about and what times, so that we can go back to our systems and cross check. So if the division engineer comes back and says that there was no trip and reclose, or there were no animals found, or anything like that, then it would come back to me. And then I would want to, look at other things. So if the initial steps that we take don't yield any results, we might suggest putting in a portable power quality meter to now get, more precisely observe what is going on and investigate what is going on. So what I do is it's partly root cause analysis, which is what I also did at Corning Incorporated, is trying to use data to find out what the issue is. So like in some situations, we might find out that, say, the sag is happening at 9 p.m. and that happens to be when they're turning on large loads in their system, then we would determine what's a better move should be, stagger the startups of equipment and so on and so forth. So it's really trying to get as much data as we can and make decisions based on that. So if, for instance, they find out it's a process problem, they might go outside the scope of what the utility can do, and they might need to bring in a researcher from outside.
I see. So those sags that they're seeing, say that it is a large load that they're starting up, and is that something that's also seen by the grid, say by other little girls trying to do their homework in the evening? Would they see a little dip, or is it so fast that only a process would notice it?
Some of them are long enough to be observed with the naked eye. And so that is actually part of what we do is if we see the event at one customer, we might look at other customers in the feeder and say, did everybody else see the same thing? Or did it not? And one of the awesome things about the technology has gotten where there are algorithms called disturbance detection direction. So that it tells you if the event's coming from upstream or from downstream. So is it from your plant or is it coming from the grid?
Okay. Well, I can imagine that, AMI is usually only sampling, every 15 minutes or something like that. People with your expertise are probably really looking forward to AMI 2.0, where the sampling rates are higher and transients can be detected and probably even uploaded and so forth.
we don't use AMI data. So some
You
people
don't use it
try
at
to
all.
say, oh,
Okay,
well, see what
fascinating.
the meters saw. And that is never high resolution enough for us. We're looking at milliseconds of data.
Okay, right.
So, because sometimes an engineer will come up and say, "Oh, see what this said," or "see," or let's say a customer comes in and says they have the voltage on balance
Right.
on whatever dates, and then someone says, they have data from the AMI meter, and well, it shows that on this date for the 5-minute interval there's no unbalance. And I always look at them and say, that doesn't tell us anything.
Right,
It could be
right,
happening
yeah.
when we're not seeing it.
Exactly.
So
Sample rate so
power
low.
quality. And when I did this years ago in Horning, I was always careful not to purchase an energy meter, because some manufacturers sell an energy meter with power quality capabilities. That is not the same as a power quality meter.
Yeah.
You want to, in this industry, you want to go to be as specific as possible. So
Right.
for power quality metering or data, you want to go specifically to power quality metering manufacturers.
Right, right. So is it mostly not only the tool set, but the sampling rate and the bandwidth that can actually observe
Correct.
that quick of a transient behavior?
Correct.
Very good. All right. Well, that's fascinating. I would like to touch on where are we going. Was there anything else that you wanted to cover about the current challenges and what you're facing? Because I'd also like to talk about, okay, where do we go from here? What are some of the challenges that you see on the horizon?
I think this one, I'm yet to determine if I would call this a challenge. Right now, for DER sites that are over, say, 500 kilowatts, we might say, okay, we're going to put in a recloser and we're going to put in a power quality meter. That's two different poles. So you're paying for the pole, you're paying for the labor. And then obviously you have to make sure that the safety of the technicians, of the people who will place things at the top of the pole, the equipment at the top of the pole. But it's coming. So I've seen at least one vendor now that is producing reclosers that use the same outputs of sensors that go to a power quality meter as well. So basically right now you have the recloser on one pole and you have the power quality meter on another pole. The question is, can you combine the two into one so that you don't need to waste time or money on two poles, but on one pole?
That's interesting.
That's something that, yes, that's my colleague just saw at Distributech, which I wasn't able to go to the conference.
Oh, okay.
But that solution came up, and I'm interested in finding out how many more vendors are doing the same thing.
Yeah, actually, I interviewed, I think it was G&W that has sensors built right into their reclosers, and interviewed them. It was fascinating to see how much they were fitting on one platform, so it didn't have to be multiple, but they were talking about that same challenge that you're identifying. So I would imagine others are going to be jumping on board doing that too. And I see that more and more frequently. A lot of people say, well, put a sensor here, put a sensor there. But the point you made, that's another asset that you're going to have to purchase, maintain, and then you've got the whole safety of the installers. There's a lot more to it than let's just stick another sensor. And if we can build platforms that have more of these capabilities where we're already having communications, and we already have a platform that we know how to install safely. Like, for example, you said the recloser is one of them, the substation's another, and hopefully AMI 2.0 in the future, right? That's another spot where we hopefully can start investing to get these kinds of insights into how the grid's performing, because I see that's totally the next generation. Like, for example, if I see that a utility, if one feeder is seeing a higher number of voltage transients just from a dielectric standpoint versus another one, or the transients are higher, meaning perhaps the overvoltage protection isn't doing its job, that is an indication that this asset is getting hit harder than these other assets. So it's a precursor. So I really think this is a great area for research and not just the research side, but actual development. We can really start getting into not just why did the lights blink, but how are these assets going to perform in the future? Kind of getting back to your asset management days, I think there's a connection here of what we could do in the industry. Are you seeing anything like that? Are you having conversations with people about using this other than just did the lights blink? Did the process interrupt? Can we use this data for predictive purposes to get out in front of how these assets are going to perform in the future?
From a data point of view, I was talking to a utility that is using power quality software to actually predict faults before they happen.
Okay,
So they use it from a cable point of view. So a lot of the majority of their cabling is underground.
Okay,
So they use it for that. But I've worked with companies where you've seen equipment get damaged sooner because of the frequent power quality events that they were facing.
Sure.
And then you have another customer as well that was being hit multiple times. So they couldn't see the event, but when they went to their UPS logs, uninterrupted power supply, when they looked at the logs, they saw like multiple events, and they're like, we don't like that UPS keeps picking stuff up. And they're like, we don't want our batteries to get damaged sooner. So what's going on? You guys help us know what's going on so that we can fix the problem. If not, we'll have you guys pay for new batteries. But yes, from an asset management point of view, I think power quality is very connected. It might be difficult to isolate failures and say it's strictly caused by power quality. But I think that's good research. I think it would be very useful for us to get that kind of info.
Right. And I don't know that it's power quality that's causing the problem, or it could be just a component that's arcing, right? So, but it's the same signature. It is a high frequency disturbance that power quality could identify. Like, for example, I know the AWARE system at Southern Cal Edison. I know some of the people that have worked on that, and they've been able to triangulate when something happens at a substation. How is it connected to somewhere out in the grid, and try to triangulate, where that arcing component is. And then also Eversource has a system, I think they say they're about 60 to 70% effective on overhead. If they have tree branches that are hitting the line, start triangulating those instantaneous momentary events. While it's not a problem with loads and generation, it's something that's a disturbance that's causing a potential reliability issue. And they've been able to roll trucks and find things. I think 60 to 70% of the time they've been able to find root cause. So I know some people are working in this area, and that's why I'm fascinated with your work, because obviously it has a very practical implication of delivery and standards. But I think there's this whole other area that we could potentially use these technologies and really benefit society and really the affordability and reliability and resilience of the grid. So that's very forward thinking. Any other thoughts about the future and what's coming down from a horizon standpoint?
Sure, of course you have. Everyone's talking about AI. I've thought about it for some time, and I know that AI can't replace the job of a power quality engineer.
No.
Because there's just some thinking that needs to go behind it. It still requires that even if the engineer is going to use AI or use AI tools, machine learning or other algorithms, you still need someone who's going to program that into. So I'm curious as to how AI will influence or affect the power quality space over time.
Yeah. Well, I think it will. And certainly these days, AI is a big umbrella, right? Big tent. And, machine learning can, people say, oh, it doesn't exist in there. But I think it does. I think it's part of the, especially physical AI, being able to bring that data in from multi-sources and start making sense of just massive amount of data. I think that's what it does well with humans to help it learn the physics aspects. Like, for example, I know one utility, a couple utilities have been very successful using, in this case, slow sampling rate of AMI to detect shorts in windings of transformers, right? So if it's consistently high or consistently low, as compared to the rest of the feeder, they know that that transformer has a winding issue. Or underground low voltage cable, or even overhead voltage cable, an aluminum, it starts to have resistance, and at some point it creates a brownout for that particular meter, and that's an indication that wire itself has a problem. So I really am excited about this junction of asset management and the quality of the grid, and then as we bring the distributed energy resources in, I can see like Bob Hefner in Texas there, one of the universities there, is working to see, okay, so if we have these transients coming onto the system, we know that that's going to cause a difference for connectors, for even the coils of transformers. A lot of these components are going to behave differently under these events because they're so much more frequent, right? We're seeing sometimes switching power supplies of multiple transients per cycle. It's not just an event every so often. So I'm very fascinated with this area, and I think you could have a whole career just in this area doing research and pulling. But I want to also get to some of the other areas that you're working on before we move on. Go ahead.
Something.
Sure.
We're actually going to. I'm hosting a power quality panel session at the
You are?
IEEE T&D conference.
Oh,
That's
fantastic.
coming up in Chicago. So the panel includes an engineer from a consultant from Enernex.
Oh, I've heard
They're
that.
talking about data centers and power quality. And then we will have someone from Elspec, which manufactures power quality meters.
Okay.
And then myself. So we will touch on a whole range of topics around power quality.
Oh, I'll have to check that out. And we'll look that up. IEEE T&D, and we can probably look under your name and probably find it that very quickly, huh? Well, that's great. That's really great. I'll be there as well with a panel.
Wonderful.
And so moderating a panel with a couple utilities. Anyway, looking forward to seeing you there. Let's see. I want to talk a little bit about. Well, I have a few short questions before we wrap. Quick lightning round of a couple questions that I typically ask our guests. One of them is someone getting into the industry that's just making a start. Where would you suggest? Do you have a tip for somebody who's just getting a start in the industry?
Sure. For this one, I was going to be a sneak peek. I'm actually going to be talking about that during a webinar on Monday with engineer Evelyn Carpenter, who is the CEO of Envera Energy. And she's going to be I asked her specifically this question, and she's going to be sharing a number of free training resources.
Okay.
So my answer to your question is read, learn as much as possible. So take as many courses as you can. Some of the courses can be expensive, but apparently there are some Ivy League universities that have put out free resources on to different topics, interconnection and clean energy and DERs. So it's just a lot of reading. So like for instance, for me, when I was doing asset management, what I had in mind was mostly transformers and distribution wood poles, so conventional power generation. Things are obviously changing.
Right.
You with the mini grids and micro grids and solar and so on. So for me, it's a lot of reading on my part. And so I would say the same for others, because my background in electrical engineering wasn't power. When I moved from Nigeria to the US, the university I went to did not have a power program, unfortunately. So I excelled in digital signal processing. So my background was actually in digital signal processing.
Okay.
So it took me quite some effort to try to overcome the hurdles of not actually getting learning the
Right.
power system, power
Mhm.
systems basics. I had to learn that on my own. So I continue to learn. And I've seen people come from other walks of life and just step into the clean energy space, like people with backgrounds in biology or in environmental science, and they're coming in and they're doing engineering, clean energy engineering. So I think being open to learning and growing is a
Mm.
big deal. And to close out, I would say networking. Find
Right.
people on LinkedIn that are doing this kind of stuff you're interested in and talk to them. And that way you just get knowledgeable about what's going on in the industry.
Be curious and get a mentor, huh? Yeah. Well, that's great advice. So two more questions here. So something you've learned recently that you think others in the power industry should know, something that you've run across that you'd like to share?
That's a hard one. I don't know if I would say something I've come across that I would like to share. I think it's more of a concept.
Okay.
I find sometimes with different companies or utilities is they're trying to figure stuff out themselves and they're just kind of pigeonholed in their thinking.
Mm.
I come from a background of I network a lot, and
Mhm.
my Ph.D, like working in the EE department, I interfaced with civil engineering a lot. And they had told me this is the first time ever that electrical engineering is ever doing research with another department. So
Okay.
working in this space, I've had to talk to like San Diego Gas and Electric and Con Edison, and so
Mhm.
different utilities to see what they're doing and
Right.
how to apply it and improve. So I
Mhm.
think if I had to give any kind of advice, that's what I would say is figure out what other people are doing and see how you can benchmark and improve.
Though that's great advice. I think it's key, and it's really a fundamental human key to be humble enough to work with others and to ask questions, right? If we just try to figure it out ourselves or what we've always done, we're probably not going to be very efficient. And last of our lightning round questions, something that we should be watching in the future, some technology, some innovation. It could be something small, it doesn't have to be, but something you've seen in your, the work that you've done with others, the conferences. What should we be thinking about in the next year? What should we be watching?
Potentially, if I stick to the power quality space, there are people are manufacturing small appliances that you could plug into a wall that do some kind of power quality analysis to let you know what things
Mm,
look like in your home.
interesting.
So as opposed to when we put in portable meters, we're putting in Rogowski coils and clamps on in panels, and we're leaving that in for 2 weeks. And then
Right.
in bigger settings, we are installing these things to stay. But what would happen is, even for industry, if they begin to use these mini, or if we can produce mini appliances that we can plug right into the wall and see what we need to see and make
Mhm.
decisions even quicker than we are making right now.
Interesting. My insurance company just sent out a note saying they have a wall thing they want us to install. I thought, is this a joke? You know, so I did a little research, and yeah, it's legit. You know, you can see patterns of different disturbances, and they say that they can eliminate some fires in homes. They think by detecting
Is that
signatures.
the one
So
that gives you a score or index or something?
I didn't research it that far. I think the brand is
Okay.
Ting. I don't know. I almost thought, is this
Yes.
a placebo? Is this a joke?
There's a
But
popular power quality engineer behind behind it. So
okay,
yeah.
fascinating. Very good. Well, this has been great. Is there anything else you'd like to tell us? Oh, actually, I know that there's something else you'd like to tell us about in your IEEE
Yes.
work and really the work for the greater good of the industry. Tell us about the hackathon, right?
Yes, there is a
Yeah.
hackathon that's coming up. The website
Mm.
is Aneru, so ANNERU.com/hackathon.
Okay.
And as you know, I got into power because of the situation I faced in Nigeria. So a lot of sub-Saharan Africa, more than 500 million people are living without access to electricity. And then we have the huge problem of affordability in the US. Almost every week, there's a news article in different parts of the country talking about affordability, which is something that used to be just an African problem, but now it's here. So the hackathon is looking at, we're targeting idea generators, so people who have ideas of how to fix the problem of affordability, how to reimagine it, people who want to fix the problem of power access, energy access in Africa. So we are giving you the opportunity to share your ideas, and then we're going to select the winners, and the winners will have a good cash prize. So we're looking to partner with different companies and utilities in the US and around the world.
Well, that sounds like a noble effort, and someone like yourself, I can see coming from that background, would have a tremendous passion about, and someone who is a great spokesperson for that work. So thank you for telling us about that. We'll have to put that in the link so that people can find you and the organization. Well, Urenna, this has been fantastic. I really enjoyed hearing about how power quality has such a role to play in the industry, and really your experience. Anything else that you'd like to tell our guests, and any concluding remarks before we conclude?
I just want to say thanks to Ben for having me here and staying in touch. It's been a pleasure knowing you, and it's been a pleasure being on your show.
Well, thank you, and we'll be in touch.